Hey everybody, how you doing? Today or yesterday in class, we did an introduction to logs, which we learned was the inverse of the exponential function. So let's take a look at that. We're gonna do some examples today, and this is meant to be an introduction to logarithms. As we talked about yesterday, we took the inverse of y equals b to the x, which became x equals b to the y. And then somewhere out there in the math universe, they came up with the log formula, y equals log base b of x. We'll talk more later on about the history of log, so to speak. I just want to introduce you to the formula today, and it needs to be memorized. And the sooner you memorize it, the better. I always remember it from looking at the log formula, b to the y equals x, b to the y equals x, b to the y equals x. I've done so many log problems, hundreds of them, by always saying b to the y equals x. This is what I remember, b to the y equals x. So, part one, they're going to give you a problem in exponential form, and we need to transfer it into logarithmic form. And so it's going to be some log base b, or some base of some number equals like the other number. And I always remember b to the y equals x. B, which is the base, so the base is 5. 5 to the b to the y, b to the 3, 5 to the 3 is 125. This is easiest. I actually have a hard time writing exponents as a log. I'm much better at writing logs as exponents, but it's actually easiest for me if I write it down first. And when I do that, I usually think about it this way, that I remember that log equals log base b of x, and then I know that if I look at that, that b to the y equals x, b to the y equals x. So in this case, when I have 2 to the negative 5 equals 1 over 32, the y is the exponent, so negative 5 equals log, the base is the same as the base from the from the last chapter, base 2, and then it's 1 over 32. So 2 to the negative 5 equals 1 over 32, or log base 2 of 1 over 32 equals negative 5. All right, that's rewriting as a log. Like I said before, I am much more comfortable going from a log to an exponent, because I look at the log and I think b to the y equals x, b to the y equals x. 3 to the 4 equals 81, which is true. b to the y equals x, b to the y equals x. So 7 to the negative 2, that is equal to 1 over 49. 1 over 49, not 1 over 49, not 1 over 149. So that's true. So we have rewritten it as an exponent. b to the y equals x, b to the y equals x. Part 3. These are the problems right here. Oh, wait a minute. I actually have a number 3 as rewrite as an exponent. What happens if they don't give us a base? So in example 3 here, what if they tell me that log of 100 equals 2, and there's no number there? If no number, if no base, it is a 10. Base 10. So this is equivalent to log base 10 of 100 equals 2. And now you go, b to the y equals x. 10 to the 2 equals 100, which is a true statement. So if no written base, it is a 10. Kind of like if when you have a square root, if there's no number there, you know it's a 2. Just like if you had an x and there's no number in front, you know it's a 1. Just like if you had an x and there's no fraction, it's over 1. Sometimes they don't put things and there's a number that you just need to know. And in this case, that number is a 10. Mainly because we're in a base 10 society. So if they don't write it, we're doing the normal base. Okay, so now evaluate. This is the most important problems out of this lesson here. They're going to give us this, and we're just going to have to figure it out. So in this case, it's kind of like this, that I have this x, and there's no number there, but we do know that it happens to be a 10. So 10 to the, 10 to the x equals 100, b to the y equals x. So then what number allows this to be true? 10 squared is 100, so x equals 2. That's one way of thinking about it, just going x equals 2. What I really did is I used change of base formula, and 10 to the x is the same thing as 10 squared. And now that the bases are the same, I know that x is equal to 2. Just another way of thinking about it. Example 2. Log no base, just log of 1 over 10. That's equal to x. There's no number there, so it's assumed it's a 10. 10 to the x equals 1 over 10. Well, 1 over 10 is the same thing as 10 to the negative 1. So x is equal to negative 1. Log base 464, if that's equal to x. A to the b equals x. 4 to the x equals 64. 4 to what power is 64? That is 3. So x equals 3. Last one. Log base 3 of 1 over 81, that is equal to some number. So b to the y equals x. 3 to the x equals 1 over 81. 1 over 81, that's 3 to the negative 4. So x is negative 4. Okay, everybody, that was some just straight up log problems. And then just to finish it off, I have some solve for x problems. And in this case, you just write the equation as it sees it. Change it to exponents. B to the y equals x. 3 to the x equals 81. 3 to what power is 81? That would be a 4. I think I did a problem just like that one already. Over here, b to the y equals x. X to the 5 equals 32. That's fractional exponents. You could either, two thoughts. You could either do fifth root of both sides, so fifth root of x to the 5 equals fifth root of 32. Or you could think of it as x to the 5th raised to a power of 1/5 is the same thing as 32 raised to the power of 1, not 1/2, 1/5. 32 to the 1/5 is the same thing as the 5th root of 32. No matter how you're looking at it, you're getting an answer of 2. Last one. Log base 9 of x equals 1/2. B to the y equals x. Never changes. That just says 9 to the 1/2 equals x. 1/2 power, that's the same thing as a square root. And the square root of 9 is 3. And that's it. So everybody, that is using that logarithm formula. Got to get this thing memorized before quiz time, before test time. And if you understand, if you have this formula memorized, you can figure out any logarithmic problem like we did in part 3 and part 4. And that's all I have for you today. Introduction to Logarithms. I hope you like your new friend. He's a good one, Mr. Log. Have a good day. Bye-bye.